Hello everyone, my name is Wilson and I am the Solution Architect Director at Tencent Cloud. It's my great pleasure today to introduce Tencent EdgeOne and its newly launched capabilities fighting against bots and malicious crawlers, as well as our integrated AI-powered client-side fraud mitigation module. Joining me today, we have Eric Yan, our Senior Product Specialist, who will walk you through a live demo of how the product works and the high-level steps required for integration. First of all, let's see what customer pain points we are trying to address. Across industries, financial services, fintech and crypto exchanges, e-commerce platforms, airlines, travel, transportation, and ticket booking systems, and even gaming environment with promotions and gift rewarding sites. Application owners share a common goal to engage with real users, especially paying customers. They aim to drive genuine participation, interaction, and high-level digital experiences from their users or players. However, more and more bots and crawlers constantly attempt to mimic human behavior and exploit application workflows. While some automated activities might be from partners and certainly acceptable, many are harmful, consuming system resources, degrading user experiences, and directly competing with legitimate users. Over the years, Tencent has accumulated extensive expertise in identifying and managing these threats and transformed this experience into a suite of productized components, such as Tencent CAPTCHA and RCE, our risk control engine, which are already widely used by our existing customers as standalone subscription services. On the other hand, Tencent EdgeOne has long served as an integrated, all-in-one edge delivery, protection, and compute platform, combining DDoS mitigation, ACLs, rate limiting, WAF, and signature-based bot mitigation with core CDN capabilities, such as caching and global performance optimization. With this new release, we are adding the latest piece to the puzzle, delivering a fully comprehensive and seamless experience across our end-to-end protect perform platform at the edge. As a high-level overview, Tencent EdgeOne now includes a new framework that unifies multiple risk control components, seamlessly integrated with EdgeOne's native security engine, such as client reputation and user agent intelligence, to differentiate real users, good bots, and malicious ones. We provide client-side device environment check and AI-driven device reputation scoring through Tencent RCE. In addition, Tencent CAPTCHA contributes user telemetry pattern detection, all tied together using a unified but multi-factor device ID. This enables application owners to establish behavioral correlation across multiple user IDs and multiple device IDs, revealing patterns that are otherwise difficult to detect. Based on machine learning insights and device reputation scores, policies can be further configured to block suspicious or high-risk requests directly at the edge level. Let's take the RCE client attestation module as an example to illustrate how we determine whether a request is harmful, legitimate, or suspicious. RCE can be configured to generate a risk score based on a wide range of device-level signals, such as whether the device is in developer or debugging mode, whether it has been rooted or jailbroken, whether the application is running on a real device or an emulator, and whether a VPN or proxy is being used. RCE supports both SDK and JS injection, both governed through a policy-driven client attestation process managed in the EdgeOne console. Based on the risk scores returned from this attestation workflow, EdgeOne users can configure their security policies to either block, challenge, or monitor incoming requests. They can also introduce additional on-demand verification steps, such as Tencent CAPTCHA, in either visible or invisible mode, to further validate users' authenticity whether needed. A typical client attestation workflow begins with device check. The SDK or injected JavaScript perform a series of inspections, and the results are then encrypted and attached to subsequent requests as embedded risk control tags. EdgeOne extract these tokens or tags and send them to attesters like RCE. Based on attestation results and pre-configured security policies, the request then continues its normal flow, either blocked with an error message or further proceeds normally to the customer's backend services if no intervention is required. When filtering bot traffic, requests may come from different access types: standard web browsers, HTML5 web views in mobile applications, or native Android iOS applications. Future support will also extend to ecosystems like WeChat mini programs. For web traffic, RCE and CAPTCHA are integrated through SDKs or injected JavaScript, enabling client-side environment checks and behavioral detection. EdgeOne can also dynamically render interactive CAPTCHA components with verification results sent back to policy evaluation. On mobile applications, customers integrate our SDK into their business logic and attach risk control tags to API requests. EdgeOne extracts these information and forwards it to RCE for assessment. Together, this provides unified protection and consistent policy enforcement across browsers, web view, and native application access channels. Integrating client attestation involves more client-side work than a traditional EdgeOne setup. The customer's development team must embed the SDK into their application and determine whether the attestation process should be triggered within their business workflow. Before configuring attestation, all relevant pages must already be delivered through EdgeOne with the correct site delivery settings. We also strongly recommend an end-to-end workflow review involving both EdgeOne engineers and the customer's developers. This ensures the business logic and protection logic are fully understood, aligned, and correctly implemented. SDK integration can proceed in parallel with EdgeOne policy configuration, as both of the tasks take time to complete. Tencent Edge engineers and the customer's development team will then collaborate to test, validate, fine-tune policies, and manage false positives. Here is a more detailed deep dive into the SDK integration workflow. When no prior client attestation exists, EdgeOne returns an HTTP 428 challenge. The client must read this challenge, extract the instructions, and trigger the SDK accordingly. The SDK then performs the required verification steps, such as device environment check and behavioral data collection, using modules like RCE or CAPTCHA. After completing these tasks, the SDK generates an encrypted attestation token that summarizes the device risk posture. The application then sends a follow-up API request carrying these tokens. Since the token is encrypted and opaque to the client, its only role is to forward the token to EdgeOne. When EdgeOne receives the request, it extracts and decrypts the token, evaluates the attestation result, and applies the configured security policies to determine whether the request should be accepted, challenged, or blocked. In short, the client must handle three fundamental tasks: process the 402 challenge returned by the EdgeOne, invoke the SDK to carry out the required verification, attach the generated attestation credential to subsequent API requests, so EdgeOne can validate the client and apply the appropriate security policies. Here is a consolidated overview of the attestation workflow and how it integrates with EdgeOne's native security modules, including WAF managed rules, customer rule engines, rate limiting, and basic bot management controls. Please note the execution sequence shown on the left. The pink color client attestation module is an optional plugin with EdgeOne's broader security inspection pipeline. With that, I'll hand the session over to our senior solution architect, Eric Yan, who will walk through a live demo of the solution in a real application scenario, showing how suspicious behavior is detected, mitigated, and managed in real time. We will also be releasing a white paper covering this entire introduction, along with the associated demos available for everyone to download. Thank you, everyone. And over to you, Eric.
Oh, thank you, Wilson. Hi, everyone. This is Eric from Tencent Cloud. I'm a product solution architect. To better showcase our latest advancement in EdgeOne, I have developed a demo application called EdgeOne Bank. The application simulates 4 common business scenarios: user registration, login, transfer, and top-up. Each of these has its own API endpoint, which represents the core interface that we need to protect. To begin with, let's take a look at our backend configurations. Now, the first step is to use this advanced capability, is to register attesters. To begin, we simply click the Add Attester button. Notice here, the provider is CAPTCHA and RCE. So to use RCE, we need to enable RCE on Tencent Cloud. After enable, they will provide us with a channel ID. We then enable it here. In my case, I have already registered 3 attesters: Bank with CAPTCHA, Bank invisible CAPTCHA, and Bank RCE. After we register our attesters, then we need to define our API endpoint. Here, we can do so by adding API service. I have already added our online banking APIs. The base path is API v1, and here we defined register, login, top up, and transfer. After we define attesters and APIs, we then use them in our security policy templates. I have already created the online banking templates. Notice that EdgeOne provides a layered process. So the request first goes through exception rules, then custom rules, then through rate limiting, then it reaches the bot management rules. And our client attestation is part of the bot management rules. For our register interface, this is the rule for it. Let's click it. So we can see for this register interface, we are using visible CAPTCHA to give it a score. If it's a low risk request, we then keep the action in monitor mode. If a medium risk, we still monitor it. But if it's a high risk request, we then can block it. Now, how do we define this score range? It's super simple. Let's click Edit. We can simply drag this sidebar to define what is low risk request, what is medium risk request, and what is high risk requests. So this is a rule for register interface. Now let's take a look at the login interface. For login interface, we are using RCE as the tester. For browser web view, if it is low risk request, we will keep it in monitor mode. If it's a medium risk request, we will then present a CAPTCHA as a challenge. However, if we are high risk request, we can simply block it. Similar for native Android apps. For top-up interface, because money flows into the system and it's relatively low risk, so all the actions are in monitor mode. For transfer interface, we are very conservative because it involves money flows from one person to another person. So we only allow low-risk requests to pass, where block those medium-risk requests and high-risk requests. Now let's take a look at our application. So the application is hosted on onlinebanking.wedgephotos.top. The first step is to register a user. Let's click the register button. We create a demo somebody and the last name somebody at gmail.com. When you play with our application, be sure to provide an email address that can actually receive emails, because a validation link will be sent to this email address. Give it a name. Now remember, our rule said we will use CAPTCHA to validate against this register interface. Let's say once the CAPTCHA appears, click register. Here's CAPTCHA. I'm a human. Now, if I'm a bot, I would then not be able to pass this. Now I'm a real human. I can pass this CAPTCHA challenge. All right, registering successful. Now we will need to click the link in our email. Then we can log in. Now let's log in. Login successful. Let's top up $8 into this account to make this a whole. Top up is successful. Now let's transfer money to see whether this is also successful. Confirm transfer. All right, our transfer action is successful. We can monitor what's happening at the backend through this UUID here. EdgeOne provides an application called Web Security Analysis. From here, we can simply paste our UUID here, and then we can see what's happening behind the scene. The log usually comes in 2 minutes time. Let's refresh. Here's our log. Let's check our log samples here. Scroll down. So this is me. I'm from Singapore, and this is my request ID. I'm visiting online banking.wedgephotos.top, and this is my user agent. Here, RCE gives us a score 0. Also, visible CAPTCHA gives us a score 0, because we are using a completely normal browser. So, according to this rule, for transfer, we are low-risk request, and our transfer action is successful. Now let's try a not so normal case. Here, I open a incognito window. Meanwhile, I open the debugging window here. Now let's try to log in. We can see that the CAPTCHA comes. We pass the CAPTCHA. All right, login successful. Again, let's top up $8 into this account. Right, top up successful. Now let's try transfer. Transfer failed. Let's see what happened. Again, we paste our UUID here. Confirm. Notice that this UUID 116 something is obtained from the response header. In our response header, there is something called EOLog UUID, and this value is exactly the same one. Let's analyze what happened. Let's refresh. The result is block. Let's see what happened. Still, this is me, my user agent. Here, RCE gave us a score 15, and bank with CAPTCHA gave us a score 0. Why it gave us score 15? Because it thinks we are in debug mode and we are in incognito mode. Fair enough. So according to our rules, we only allow low-risk requests to pass. So this is a medium request, so it got blocked. Fair enough. Because a normal user, a general user, wouldn't know how to enter incognito mode and how to open the debug window. All right. Now let's imagine that we are running a campaign that offers special bonus to newly registered users. This kind of promotion often attracts bonus hunters who will use automatic scripts to take advantage of our campaign. So how do we make sure that the benefits are only given to those real users, not those bonus hunters? In this case, our registration API will be the main target. Let's see what the rule is our register interface. So first, we will use CAPTCHA to give it a score, to present a challenge to the customer. If the user is blocked, then he got blocked. However, if he is able to pass, but CAPTCHA thinks it's a high-risk request, again, we will block it. Now let's see this demo. Here, I'm using Selenium as our automation tool. Let's run it. Node, headings browser, register. Now, a moment, register. Right. Notice that here, it says Chrome is being controlled by automated test software, this warning message. So if this automation tool is unable to pass this CAPTCHA challenge, then it stops. Our register interface remains unbothered. Now, suppose I am using a super advanced or some magic to pass this CAPTCHA challenge. Can I successfully register? Right, I passed the CAPTCHA challenge. However, still our register is failed. Let's see why. Then we go to here, paste our UUID, confirm. Again, let's wait some time. Right, here log comes. We refresh again. Give it more time. Here is get blocked. Let's see what happened. Again, this is me. I'm visiting the register path. API v1 was register. Here, visible CAPTCHA gives us a score 18. Why it gives us a score 18? Because it detects that I have used the CAPTCHA in a short time too often. I have used it 3 times the CAPTCHA present. So triggers the rate limiting rule of this CAPTCHA. Then it thinks our browser is abnormal because the browser is controlled by automation software. So it gives us a score 18. Fair enough. According to our rule, 18 falls into these high-risk requests. So it got blocked. Totally makes sense. Now let's try mimic the credential stuffing attack or brute force attack. In this case, somebody is using a large set of usernames and passwords to validate against our login interface and to see which one is still valid. Let's see how EdgeOne behaves in this scenario. Again, I'm using Selenium as the browser. Here, we run node browser login. Again, notice the warning message, Chrome is being controlled by automated software. Try login. Right, our login failed. Let's see what happened. We paste our UUID here. And remember that our rules, our tester for register and login is different. For register, we are using the CAPTCHA as the tester. However, this time, for login interface, we are using RCE as the tester. If RCE thinks it's high-risk request, and it will get blocked. If it sends medium-risk request, it will present a CAPTCHA challenge. Here, we just got blocked, so the score must be between these two numbers, right? Here, the log comes. Let's see the log samples. We refresh. All right, got blocked. Let's expand. Still me. I'm visiting the login interface. API v1 was login. Here, RCE directly gives us score 100. Why? Because he thinks we are using a headings browser. Yes, indeed, that's true. We are using a headings browser, and it's controlled by automation tool. So you can see in these two cases that both RCE and CAPTCHA are able to stop those automated attacks. Besides web application, I have also developed an Android app called EO Bank. Now let's use Postman to monitor traffic sent from them. So this is my app on an emulator. Let's open it. So here the request comes. And also let's try login from on this emulator. Let's log in. All right, we got blocked. Login failed, and we got blocked here. This is a error code unique to EdgeOne 567. All right, we obtained EO log UID, copy, and we paste it here. Confirm. All right, here's the log. Let's see what happened. We refresh, blocks. Let's expand to see the details. Here, RCE gives us score 100 directly for our Android application. Why? Because it thinks we are running the application on emulator, and we are using network proxy, which is true. I'm using Proxyman. Also, it thinks the app is in developer mode and our room is in dev mode. We also have USB debugging. That's all true. So it's fair enough to give us a score of 100 and blocked our login. I have also installed my app on an Android phone. This is a true phone. Again, let's monitor the logs through Proxyman. Now I'm operating it on my phone. We go to your bank. You see here log comes, this is new. Now let's try login. Login. Here we see this login. Now let's transfer, let's top up first. Say want to top up 100 to my account. Top up. So this is the top up account, and it's the body 100. Now let's try to transfer money out of this account. All right, transfer is also successful. Let's see what happened. This is the log UUID. Copy. Let's paste it. Confirm. Let's refresh. Still again, let's give it 2 minutes. Here's the log. Let's see the details. In this case, RCE gives us score 10. Why 10? Because it thinks that we are using no SIM card, which is true. I'm not using the phone. This is just for demo purpose, so it got no SIM card. And we are using network proxy, so it gives us a score 10. According to our rule, score 10 are allowed to transfer, so this is totally expected. That concludes my demo for today. I believe that after these 6 scenarios, you now have a clear understanding of how EdgeOne, the risk control engine, and CAPTCHA can work together to protect our applications in real time. In summary, this integrated solution delivers a unified end-to-end protection platform, detecting risks in the environment where your application runs, identifying suspicious behaviors, and responding dynamically by presenting a CAPTCHA challenge. Thank you for joining me today. To learn more, please do visit edgeone.ai or reach out to Tencent Cloud teams. Thank you.
I saw some of the questions. So the first one is, can you explain more about how Tencent identifies bot traffic and how accurate is it compared with other vendors? Our approach combines multiple detection mechanisms rather than relying on any single signal. With the EO native bot manager, we have the user signature-based detection and IP reputation analysis. And with the risk control engine, or RCE, we have the device reputation and client-side environment checks. For instance, debugging mode, VPN proxy being used, emulator behavior, so on and so forth. And with CAPTCHA, we are adding the behavioral signals such as mouse movements and keystrokes from both visible and invisible challenges. All of these inputs are processed using the AI or machine learning models to generate quantifiable risk scores. Application owners can then tailor mitigation strategies based on these business logics and security posture. Our engineers and service team are also available to help fine-tuning these policies. Because we incorporate client-side environment intelligence in addition to server-side data, we believe our detection accuracy can exceed that of many existing solutions. But we are always open to detailed discussion and proof of concept testing. Here is another question. What if a hacker obtains an EO attest token and replaces it against the system? What will happen? So the EO attest token includes the client's IP address as part of the encoded data. Our backend validates the token against the originating IP. If the IP does not match, the request is immediately blocked. In other words, simply replaying the token from another IP will not allow the attacker to access the APIs. Another question, what if a hacker obtains a valid EO attest token and replaces it from their own machine using scripts? As long as the token remains valid, it's not expired, the request may pass the client attestation check. However, it will still need to pass all the preceding EdgeOne security layers, such as custom rules, rate limiting, IP reputation checks, and intelligent bot detection, before it even reaches the client attestation stage. Script-based replay attacks are typically blocked at these earlier stages, especially by rate limiting and bot detection mechanisms. Here is another question. If my existing older application version has not integrated the EdgeOne SDK, can I still use the solution? Without integrating the EO SDK, the application cannot proceed the 428 challenge, which means the request will be blocked. Our recommendation is to enable client attestation only on application versions that have the EO SDK integrated. For older versions, you may either enforce an upgrade or configure exclusions, exceptional rules for those versions by passing client attestation. Let's see, maybe the last question. I have already integrated another vendor's SDK. Can I still adopt this solution? Can you ensure a smooth cutover? Yes, we fully support smooth transitions from other vendors and have successful cases. It's important to note that SDK functions are sort of libraries. An application can import multiple libraries at the same time. This means your application can integrate both SDKs concurrently. When traffic is routed through vendor A, their detection and mitigation logics apply. When it's routed through vendor B, EdgeOne for instance, our mechanism take over. This allows a flexible and seamless migration path. For the matter of time, let's wrap it up today. And in case any further question, you can always send to us via email, or you can scan the QR code to view the live demo we showed today. Thanks everyone, and have a nice rest of the day or evening. Thank you. Bye.